Let's start with the terrifying and slowly work our way up towards the even more terrifying. Number 5, the big bounce. Yeah, I know. Before we begin, I want to make one thing absolutely clear. If I see a single your mom joke in the comments, you will be banned. The Big Bounce is a proposed explanation for the beginning and the end of the universe, because they go together, as you will soon find out. This theory exists partly because the Big Bang Theory successfully explains how the universe evolved after its earliest moments, but completely breaks down when we investigate the very beginning, which is understandable, as therapists do this all the time. If we mathematically trace the universe backward, everything becomes hotter, denser, and more compressed until it reaches what appears to be a singularity, a point of infinite density. By this point, not even Einstein can help us because his theories no longer work. Pathetic. Naturally, because we don't know is obviously not a good enough answer in science, we quickly got to work. And if you were thinking the best way to solve any problem in science is by carefully understanding it, testing it, and gradually constructing a better theory, you would, of course, be completely wrong. The best way to solve any problem is just to remove the problem completely. And that's exactly what Wolfgang Priester and Hans Joachim Blomy did in 1987. Basically, long story short, they proposed that the Big Bang was not actually the beginning of the universe, but instead simply the transition between an infinite cycle of reoccurring universes. This seemed like common sense to Wolfgang and Hans, because if we are in an expanding universe, that must mean that the previous universe had been contracting. Then, quantum effects eventually become dominant at super high densities, which causes the universe to rebound outward again. In other words, the Big Bang is preceded by a big crunch. More on that later. And then the cycle repeats, which means somewhere across an incomprehensible number of previous universes, there may have been a version of you that didn't fumble the bag. And I know what you're thinking. This entire theory sounds highly speculative, and it is. So let's talk a bit about how it's supposed to work. But don't worry, I will be sure to make this part quick because, let's be honest, nobody really cares about this stuff anyway. The main idea is quantum gravity, which nobody really knows anything about yet. So we're off to a great start. At extremely small scales, such as the Planck scale, where even modern physics breaks down, it is assumed the structure of space-time itself behaves very differently than what we observe at extremely large scales, such as your mother. At this tiny scale, instead of allowing infinite density, quantum effects may generate a repulsive force that prevents total collapse, meaning a bounce and explosion instead of a sad, quiet whimper, which we can all agree is so much cooler. But the real question, the question that determines all of legitimate science is, can we test it? And we can. If our universe emerged from a previous one, traces of that event might still exist in the oldest light in the universe, the cosmic microwave background, which is faint radiation left over from the early universe. And I don't expect any of this to make sense to you, but to highly trained cosmologists and me, it is incredibly important. And what we found was nothing short of unbelievable. There was no bound signature and we scrapped the whole idea. This theory, however, is still an active area of research, but I think it is more of just an excuse for scientists to do something with their time because, after all, once we figured out how to make dinosaurs into chicken nuggets, humanity had already peaked. So what's the point in figuring anything else out? Number 4, the Big Freeze. The Big Freeze is also commonly known as the heat death of the universe, and it is the leading general scenario for how the universe is going to end. So listen up, because we cannot let this happen on our watch. This theory was brought to us by Lord Kelvin, who had just applied the newly developed laws of thermodynamics to the entire universe. In 1852, Lord Kelvin argued that useful mechanical energy naturally dissipates into heat. Since this process can't be reversed, he concluded that the universe itself must eventually run down like a clock, losing its energy in the process. Ultimately, after however many years, no useful motion will remain, and the universe will die. This also led us to find out that the universe wasn't infinitely old like previously thought. If it were infinitely old, stars should have burned out a long time ago, and temperatures should have already equaled out. So clearly, everybody was wrong. To better understand the Big Freeze, let's put this theory into action. Over the next trillions and trillions of years, stars continue to burn, galaxies continue to evolve, and you still don't have a girlfriend. Eventually, given enough time, stars will run out of that sweet gas they need to create new stars. Existing stars will then die, turning into white dwarfs, neutron stars, and black holes, depending on their size. Over unimaginable periods of time, galaxies beyond our local gravitationally bound region will move so far away that their light will no longer reach us. Any future observer in our galaxy may look into the sky and see no evidence that other galaxies ever existed. Eventually, what will be left is black holes, but even those don't last forever because Stephen Hawking invented a way for them to die. The largest possible black holes may last up to 10 to the 106 years before disappearing completely. This is a 1 followed by 106 zeros. A number so large that writing it down would be a complete waste of your time. So I did it for you. Once the final black holes disappear, the universe enters what is commonly called the dark era, as if it wasn't completely dark before it. In this era, almost nothing remains except for a pitiful sea of photons, neutrinos, electrons, and other low-energy particles scattered across a universe that is, in fact, still expanding. Matter becomes so sparse that, like your social life, meaningful interactions are almost non-existent. At this point, the universe becomes cold, dark, and essentially inactive forever. And I'm sure we can all agree, for something that began with the biggest explosion in history, this is an incredibly pathetic way to die. Fortunately, this theory is not proven, which means the universe could still surprise us. Unfortunately, considering the other things on this list, the surprise probably sucks. Number 3, the Big Crunch. This is another famous but terrifying theory for how the universe could end, but unlike the Big Bounce, the traditional Big Crunch does not predict a new beginning. It is final. This theory basically goes like this. The universe continues to expand, but given enough time, that expansion will stop. Not only will it stop, but it will also reverse direction, but much like your mother, it will begin to collapse under its own gravity. Over time, galaxies, stars, and all matter will be pulled closer together until the entire universe is compressed into an infinitely hot, infinitely dense state, a singularity. In other words, this is just the Big Bang in reverse. This idea goes all the way back to 1922 when Russian physicist Alexander Friedman, after setting down his vodka, developed equations showing that Einstein's universe did not need to remain static. Pathetic. Depending on how much matter it contains, the universe could either expand forever or eventually collapse, which are two very different outcomes. But in this case, if the universe contained enough matter, gravity would eventually overcome the outward momentum created by the Big Bang. Once contraction begins, gravity would pull everything together faster and faster until the universe completely collapses. Luckily for us, even if the expansion of the universe ever reversed, the process would happen over billions of years, which means we're running out of time. During the final stages, the night sky would become increasingly bright as galaxies move closer together. During the final minutes of the universe, temperatures would become so extreme that atoms could no longer exist. Atoms would break into their fundamental particles, while black holes would merge into increasingly larger ones. Eventually, every remaining particle in every black hole would be crushed together into one infinitely hot, infinitely dense singularity where space and time themselves would cease to exist. And then, obviously, it will bounce back again, thanks to Wolfgang. Number 2, the Big Rip. I know what you're thinking. The Big Rip sounds like what happens when you attempt the splits in genes, and I'm here to tell you that that is basically exactly what it is. Unlike the Big Freeze, where the universe slowly dies from a lack of usable energy, or the Big Crunch, where gravity pulls everything back together, the Big Rip suggests that the universe is torn apart by its own expansion. This would take a long time to explain, and nobody has that kind of time, so I will quickly skim over the details. In this scenario, the mysterious force known as dark energy becomes stronger and stronger over time. Dark energy is a force that is driving the expansion of the universe that nobody really understands. So we're off to a great start. Eventually, it overwhelms every force in nature, progressively ripping apart galaxy clusters, galaxies, solar systems, planets, stars, and finally, even atoms and their subatomic particles. By the end, every distance between particles becomes infinitely large, leaving nothing intact. If I were to put this theory simply, it is just a big freeze on steroids. Instead of all big things moving far away, even the small ones do. I also know lots of you will favor this theory because it is the only one where size doesn't matter. Back in the day, this was quite a possible and terrifying fate for the universe. Under certain estimates, the earliest Big Rip was expected to occur in roughly 152 billion years from now, meaning we have to take action now before it's too late. But after recent and more precise observations, the earliest Big Rip that is possible is roughly 200 billion years from now instead, which is a major sigh of relief. Number 1, vacuum decay. Vacuum decay is one of the most terrifying and disturbing theories for how the universe could end, and is also sometimes called false vacuum decay, because adding an extra word makes anything more terrifying. But vacuum decay is no joke. Unlike any of the other theories in this video, vacuum decay would not happen gradually. Instead, one moment you could be having the best day of your life watching this video, and then be absolutely obliterated and pulverized by space itself in the next. The theory comes from quantum field theory, which suggests that empty space isn't actually empty. Instead, it contains quantum fields with a certain amount of energy called the vacuum state. But of course, like most things, this is just a theory. Scientists believe the vacuum state we live in may not be the lowest energy state possible. Instead, our current vacuum may be metastable, which is an unnecessarily complicated word for a state that is stable enough to last billions of years, but ultimately isn't the most stable state. If that is true, then the universe could someday, at any time, transition into a lower energy true vacuum. The most widely accepted mechanism is called bubble nucleation, which is exactly what it sounds like. Because of quantum mechanics, which is a reasonably sufficient explanation, a tiny region of space could randomly tunnel into the lower energy true vacuum without any external trigger. This creates an incredibly small vacuum of true vacuum. Most tiny bubbles would immediately collapse, but if one happened to reach a critical size, it would become energetically favorable for it to continue growing. Much like your mother. Once expansion begins, the bubble wall could accelerate upward at nearly the speed of light. Nothing can move faster than the bubble, not even Usain Bolt, which, I know, is hard to believe and raise my suspicions. This means nothing inside the universe could detect it before it arrived. There would be absolutely no warning. In all seriousness, I have been lying to you about being absolutely obliterated and pulverized. Don't worry, you will be absolutely obliterated, but you might not be pulverized. Inside the bubble, the fundamental laws of physics may be completely different. The strengths of the fundamental forces holding the universe together could change. Atoms might no longer exist. Depending on the exact difference between the false and true vacuum, the effects range from relatively subtle changes in physical constants to the complete destruction of all matter. In the most extreme scenarios, every atom, every molecule, every planet, every star, and every galaxy would instantly cease to exist as the bubble passes through them. Current estimates conclude that if our vacuum is truly metastable, then the universe is expected to live on for another 10 to the 65 years, which is 7.25 billion times the current age of the universe, which means we're running out of time.